Hello my friends and welcome back to the Today Machine channel. At the Kübler Heavy Lift Center in Mannheim, the U17 submarine underwent a remarkable first. It was rotated on a pontoon. By turning the submarine around its own axis, the overall height was reduced by approximately 5 meters, allowing for safer transport through narrow passages. The operation was secured using Kübler's 500-ton crane, providing precise control during the off-center lift and rotation. Once the submarine reached Heidelberg, it made a spectacular appearance in front of the old castle, where a laser show highlighted U17 for the public. This combination of precise heavy lift engineering and public display showcased not only the technical expertise required to move such a massive object, but also the careful planning and coordination necessary to execute a transport of this scale safely and efficiently. Harekет Heavy Lifting and Project Transportation executed the movement of two 200-ton passenger ships over 250 meters to a floating dock at Tucson shipyard. The operation utilized 200 heavy-duty axle lines with 600 wheels. The convoy included 56 axle lines of self-propelled modular trailer modules with hydrostatic drive and multi-directional electronic steering, complemented by 144 axle lines of conventional THP SL heavy-duty modules. All systems were synchronized to maintain uniform load distribution, precise alignment, and safe navigation across the shipyard infrastructure. A heavy transport loadout involving a 2,000-ton vessel is executed using a combined configuration of 2x30 axle SPMTs and 2x36 axle SPMT-THP modules powered by 4 synchronized power pack units. The operation also includes handling additional ship blocks, weighing 1 400 tons and 1 600 tons. Each transporter line is hydraulically linked to maintain uniform load distribution, with axle compensation systems adjusting stroke height to counter deck unevenness and tidal variations. Steering modes, carousel, transverse, and diagonal, are applied to maintain precise alignment with the quay. Real-time data from pressure sensors and electronic load cells ensures all axle lines remain within allowable load envelopes. During final transfer, ramp gradients, ground bearing pressures, and structural deflection limits are continuously monitored to secure a controlled, stable loadout. In a first-of-its-kind operation in South Korea, a gigantic ship block was successfully transported using an unprecedented configuration of self-propelled modular transporters. The operation deployed 54 modules of Kometo MSPE Evo 26/4 halves 43 distributed across 324 axle lines, creating a highly synchronized, multi-axle transport system. Each module was powered by one of 12 high-performance power pack units, each delivering 335 kW, providing coordinated propulsion, steering, and braking control across the entire convoy. The combined system achieved a gross weight technical capacity of 19,440 tons, demonstrating the ability to move one of the largest ship blocks ever handled in the region. Precision control was critical. Each axle line had to maintain exact positioning to ensure load distribution, prevent structural stress, and guarantee safe movement along the transport path. Hydraulic steering and automated load balancing ensured the massive structure remained stable throughout the journey. even over minor inclines or uneven surfaces. This transportation involved careful planning, including route analysis, load distribution calculations, and coordination between operators controlling each segment of the convoy. The modular design of the Kometo MSPE Evo 2 allowed flexible configuration, adapting to the size and weight of the ship block. The successful completion of this operation marks a milestone in heavy-load marine engineering, demonstrating advanced capabilities in modular transporter technology, precise hydraulic control, and large-scale logistics. It showcases how modern engineering can safely and efficiently manage extraordinary loads in shipbuilding and industrial applications, setting a new benchmark for future projects. The launch of the 80-meter, 680 gross ton superyacht, currently the largest vessel ever constructed by a Turkish shipyard, required a carefully engineered heavy transport and flotation sequence executed at Bilgin Yachts, production facilities in West Istanbul Marina. The transfer operation relied on 64 axle lines of self-propelled modular transporters, SPMTs, arranged in multiple mechanically and electronically synchronized groups. 4 high-capacity power pack units supplied hydraulic and propulsion power, ensuring stable torque delivery during acceleration, inching maneuvers, and final positioning. Before movement, load calculations established precise axle distribution to remain within allowable ground-bearing pressures across the marina's reinforced transport path. The yacht's steel hull and longitudinal framing were analyzed to determine optimal support points, reducing localized stress and avoiding deformation during rolling. Each axle line operated with active hydraulic compensation, allowing continuous leveling despite minor irregularities in pavement elevation. Navigation toward the floating deck required multi-mode SPMT steering, primarily transverse and carousel, to maintain millimetric alignment with the platform's centerline. Real-time telemetry from pressure sensors, inclinometer modules, and hydraulic pressure monitors confirmed that structural loads remained within safe thresholds during ascent onto the deck. Once positioned, the yacht was set onto pre-installed keel blocks and side supports on the floating deck. The lowering process involved gradual reduction of SPMT stroke height, executed in synchronized steps to prevent torsional or longitudinal twisting of the hull. After full transfer, locking mechanisms and C-fastening points were inspected to verify stability for the subsequent float-off phase. During launch, ballasting systems on the floating deck were activated to achieve controlled immersion. Water ballast tanks were filled according to a predefined sequence to maintain trim and heel angles within narrow safety parameters. As buoyancy surpassed block reaction, the vessel separated cleanly, entering a stable floating condition. This combined heavy transport and float-off procedure demonstrates the high precision required to handle vessels of this mass and scale. In October 2019, Dacotrans executed the transport of an 800-ton industrial reactor. Due to the reactor's weight and dimensions, precise load handling was essential. A combination of self-propelled modular transporters and heavy-duty hydraulic trailers was used to evenly distribute the load across multiple axle lines, maintaining ground-bearing limits. The transport route required extensive preparation, including surveys of road cambers, bridge load capacities, and tight turns. In one section, railway tracks had to be temporarily dismantled to allow safe passage of the oversized load. At the port, the reactor was lifted onto the transport vessel and welded to the deck to secure it for the sea voyage. Upon arrival, the welds were carefully cut, and the reactor was transferred off the vessel using synchronized modular transporters. Hydraulic suspension and multi-axle steering ensured precise alignment during movement to the installation site. Real-time monitoring of load distribution, tilt, and structural stress maintained stability throughout the operation, enabling safe and accurate placement of the reactor at its final location. The transport operation executed by Nusreti Special Transport involved moving multiple chemical processing columns from the manufacturing plant of Ondrejovice Strojerny to the port of Bratislava, followed by onward routing toward the Azotara Pančevo facility in Serbia. The convoy consisted of 11 specialized transport vehicles configured for long-distance movement of oversized industrial components. The two largest units were chemical columns that, once loaded onto heavy-duty modular trailer assemblies built from Goldhofer THP axle lines with turntable systems, formed transport configurations measuring approximately 55 meters in length, 4.1 meters in width, and 5.1 meters in height with a total weight of 156 tons, and another measuring 53 meters in length, 4 meters in width, and 4.5 meters in height with a total weight of 120 tons. Tractor units included high-torque Mercedes-Benz Aerox and Actros, as well as man-heavy haulage prime movers. These units provided the required pulling force and hydraulic interface for the multi-axle platform trailers. The transport group also incorporated escort vehicles responsible for technical monitoring, route preparation, traffic control, and coordination of any temporary infrastructure adjustments. Route engineering represented a critical portion of the operation. All bridge crossings, road cambers, pavement load capacities, and overhead clearances were analyzed in advance. Dynamic load simulations help determine axle line stroke settings, articulation angles, and steering modes required for safe passage through constrained sections. The most challenging segment was the ascent and descent of the serpentine road beneath the Czerwonogórski saddle. This section required coordinated multi-axle steering, inching speed control, and constant monitoring of lateral forces. Continuous communication between tractor operators, steering technicians, and escort teams ensured that the convoys maintained safe alignment while negotiating tight curves and steep gradients. The successful passage demonstrated precise control of heavy modular transport systems under demanding topographic conditions. In 2018, a massive 800-ton ship measuring 123 meters times 17 meters times 8.6 meters was transported using a Goldhofer self-propelled modular trailer with 122 axles. The operation required precise coordination across all modules to maintain stability, balance, and safe movement of the enormous load. Each axle line was hydraulically controlled, ensuring even weight distribution and smooth navigation along the transport route. The modular trailer configuration allowed flexibility to adapt to the ship's dimensions while providing the necessary load capacity. This transport showcased the capabilities of modern heavy lift technology, demonstrating how large marine structures can be moved efficiently and safely using advanced SPMT systems in industrial-scale projects. The heavy transport of the Austal LCS Coronado, a trimaran littoral combat ship measuring approximately 127 meters in length and 31.6 meters in beam, requires a precisely engineered SPMT configuration. The vessel's displacement, exceeding 300 tons in transport condition, is supported by over 120 hydraulic axle lines, each equipped with 360 degrees electronic steering, independent suspension, and a nominal load capacity of roughly 35 to 40 tons per axle line. Multiple power pack units supply synchronized hydraulic flow and traction, maintaining a controlled travel speed of 0.8 to 1.2 kilometers per hour across the shipyard. Load sensors continuously verify pressure distribution over steel support stools positioned along the trimaran's center hull and side amas. Real-time alignment systems compensate for ground slope and elevation variations, ensuring structural stability during the move. This operation demonstrates the precision and coordination required for relocating naval vessels of this scale. Hurricane executes heavy transport and installation tasks using load engineering principles as the core of every operation. Each project is modeled with FEM to evaluate stress distribution, axle load balance, stability margins, and dynamic behavior during transport. The equipment fleet includes independently steered SPMTs, hydraulic platforms rated from 300 to 45,000 kN, low-friction skid shoes, gantry lifting systems, and PLC synchronized strandjack units. In wind energy projects, Hurricane manages tower, nacelle, and blade transport, with lifting procedures aligned to IEC load standards. Real-time load monitoring, stroke balancing, and microdisplacement control ensure structural integrity throughout each movement. The oversized transport operation involved moving a bio-waste dryer from Prerov to Bratislava. The unit was loaded onto a MAN heavy-haul tractor combined with a Goldhofer SKPH modular trailer, forming a convoy with total dimensions of 38 meters in length, 5.5 meters in width, and 5.8 meters in height, with a gross weight of 58 tons. Preparation required detailed route verification, including pavement load capacity, overhead clearances, and turning radii. The trailer's hydraulic suspension and modular steering system were adjusted to maintain stability during narrow road sections and bridge crossings. Throughout the journey, escort vehicles coordinated traffic control and monitored articulation angles, ensuring the long machine body remained centered during complex maneuvers and elevation changes. The transportation of 6 wind turbine blades, each weighing 20 tons, was completed using the Goldhofer FTV 550 blade lifter, equipped with a custom adapter for N149 type turbines. Each blade measured 74.5 meters in length with a diameter of 2.9 meters. The operation, conducted in Taspinar, Izmir, involved navigating narrow village roads and sharp turns along a 12-kilometer route. The blade lifter's hydraulic and articulation systems allowed precise control of angle, tilt, and rotation, maintaining structural integrity throughout transport. Continuous monitoring of axle loads and clearance ensured safe passage. Blades were delivered directly to the turbine installation area, demonstrating careful coordination of oversized load handling and specialized lifting technology for renewable energy applications. In early 2018, 3 transformer sets, each weighing 280 tons and manufactured by Silovye Machiny Toshiba, were transported to the Kalinin nuclear power plant. The operation required careful engineering analysis to manage the extreme weight and dimensions of the components. Transportation utilized modular axle lines to evenly distribute load across the route, ensuring pavement and bridge load capacities were not exceeded. A portal lifting system provided precise vertical positioning, while a 400-ton capacity rail transporter enabled stable horizontal movement over the track sections. Each transporter module was synchronized to maintain uniform axle loads, compensate for elevation changes, and minimize structural stresses on the transformer housings. Critical route points were analyzed for turning radii, ground bearing, and overhead clearance. Real-time monitoring of tilt, load, and alignment ensured the transformers were safely delivered and accurately positioned at the installation site, demonstrating advanced heavy-lift engineering and logistical precision for nuclear infrastructure components. The L/C 20,000-ton class caisson dock launching project involved the controlled float-off of a massive floating dock designed for heavy-lift marine operations. The caisson measured approximately 76 meters in length, 60 meters in breadth, with a designed lifting capacity of 20,000 tons. The operation required detailed engineering analysis to ensure structural integrity and stability during launch. Prior to immersion, the caisson was fabricated in a land-based casting yard and positioned on a reinforced launching platform. Hydraulic support systems and temporary skidding mechanisms maintained alignment and minimized stress concentrations along the hull. Ballast tanks were filled in a precise sequence, controlling trim and heel to achieve a uniform immersion profile. Electro-hydraulic ballast pumps allowed gradual adjustment, reducing dynamic loading during transition from dry dock to floating condition. Throughout the launch, structural sensors monitored bending moments, tilt, and load distribution, ensuring the dock remained within design parameters. Mooring lines and winch-controlled anchors provided lateral stability during the initial float-off. Upon achieving full buoyancy, the dock was navigated to its operational berth using tugs and alignment guides. Kübler specializes in transporting even the largest vessels over land, requiring extensive technical planning and precision execution. Each operation begins with a detailed route survey using advanced laser measurement systems, analyzing road widths, overhead clearances, and bridge load capacities. For some vessels, especially those with complete interior outfitting and wiring, transport in a single piece is critical, avoiding complex disassembly. Structural engineers and in-house statics experts calculate load distribution, center of gravity, and stress points to ensure the hull remains stable throughout transport. CAD software is used to model both the ship and obstacles along the route, allowing planners to simulate movements and design clearance strategies for tight turns and narrow roads. Heavy-duty modular trailers, hydraulic lifting systems, and synchronized axle lines are deployed to move the ships safely. Examples include the transport of the Marksburg from the Rhine to the Moldau Reservoir and deliveries to high-altitude lakes like the Schluchsee, where precision handling was essential to navigate restricted paths and maintain vessel integrity. The T Group Bremen transporter, operated by Camargue Transport Technik, executed one of the most impressive heavy transports ever through the Danube Valley. The transporter, designed for a payload of 150 tons, measured 71 meters in total length with a gross weight of 360 tons. The modular convoy, including lead and trailing vehicles, extended over 100 meters in total. The loaded transporter alone weighed 132 tons. To handle this extreme payload, the transporter required newly engineered trailing modules and massive 3.7-meter diameter tires, each filled with 10 tons of water for stability. The transporter is powered by a 148-horsepower Caterpillar engine and features multiple control modes, manual, remote, and fully autonomous, using radar and sensor systems to navigate complex routes. The operation required months of planning, including road reinforcement, bridge clearance analysis, and specialized route preparation. Critical points, such as a bridge with only 5.2 meters clearance, were overcome with custom-built roadway solutions. Once in operation, the vehicle can move up to 900 degrees Celsius hot steel frames, supporting industrial production around the clock. This transport represents a world first in scale, payload, and autonomous heavy lift capability. In July 2021, Spedition Kübler executed a heavy transport of a gas turbine with its boiler bridge and generator through central Munich. The convoy, including the turbine assembly and support modules, reached a total length of 97 meters and a width of nearly 6 meters, requiring meticulous route planning through narrow streets and complex intersections. The operation involved 41 axle lines on the main transporter, with additional support axles added or removed at critical points to manage turning radii and maintain load distribution. Clearance under bridges, street lamps, and overhead infrastructure was closely monitored, and temporary adjustments such as lifting tram wires were implemented. Technical teams continuously measured center of gravity, load stress, and steering angles to ensure stability while negotiating sharp turns, including the Odeonsplatz and Leopoldstrasse sections. The turbine height of 6.05 meters demanded precise ballast and suspension adjustments. This transport exemplifies advanced heavy-lift logistics, combining modular trailer technology, axle load management, and urban engineering, enabling the safe delivery of industrial-scale equipment through a dense city environment. Omega Morgan executed the relocation of a retired B-52 Stratofortress, a bomber spanning 48.5 meters in wingspan and weighing over 80 tons in transport configuration. The aircraft was supported on a custom multi-axle hydraulic platform trailer equipped with independent suspension, electronic steering, and real-time load monitoring. Wingtip clearance, fuselage bending limits, and road camber were continuously evaluated during the move. Temporary shoring, route grading, and obstacle removal ensured safe passage through tight turns and uneven terrain. The controlled travel speed of under 5 kilometers per hour reflected the precision required to maneuver an airframe of this scale without structural stress. In what's being called one of the largest industrial transports in U.S. history, 4 retired generators, each weighing an astounding 400 tons, made their journey from Southern California to Clive, Utah. These are no ordinary loads, each one tipping the scales at 800,000 pounds, and each had to be moved one at a time. To tackle this massive challenge, Perkins Specialized Transportation engineered a custom trailer over 300 feet long, nearly 20 feet tall, and as wide as a 2-lane road. It rides on 192 wheels distributed across 4 independent dollies, each with its own operator, allowing the convoy to maneuver through intersections and narrow turns with surgical precision. Power comes from the Mack Titan, a true heavy-haul beast with a 16-liter engine delivering over 600 horsepower and more than 2,000 foot-pounds of torque. Each generator required 5 trucks to move safely, bringing the total road train weight to nearly 1.5 million pounds. The 850-mile journey spanned 3 states, traversing cities, counties, and rugged terrain. Night operations in California, daylight travel in Nevada, careful navigation of grades, and temporary adjustments to roads, light poles, and overhead lines were all part of the plan. Every detail was calculated: load distribution, steering angles, suspension settings, and braking power. The Mack Titan's Allison automatic transmission and power leash engine brake ensured steady progress up steep inclines and controlled descents. After months of planning and days of careful travel, all 4 generators arrived safely at their destination, a testament to precision engineering, extreme logistics, and the power of modern heavy-haul machinery.